The Milky Way, our home galaxy, has long been thought to be the second largest galaxy in our local group until recently. However, new research from astronomers at Durham University have given us an idea of just how immense our galaxy actually is, and it is staggering. The new breakthrough research on the size of the Milky Way puts into perspective how large galaxies can actually get, and also shines a light on how little is known about one of the great mysteries of our universe, dark matter. Before diving into these new discoveries regarding the Milky Way's size, I'd like to take a moment to discuss a few facts we know about the Milky Way to provide some background. It is a large spiral-barred galaxy. Spiral galaxies are some of the most common galaxy types, and spiral-barred galaxies have a bar through the middle of them, which laces through the center of the galaxy and connects the arms of the galaxy together. The Milky Way is the home of our solar system, and our sun is one of more than 200 billion stars contained inside of it. We're about 30,000 light years from the galactic center of the Milky Way, and about 20 light years above the galactic plane. So if the Milky Way were Los Angeles, our solar system is located in the Rancho Cucamonga part of the galaxy. Up until 2018, the Milky Way was considered to be the second largest galaxy in the local group, after Andromeda. And the diameter of the Milky Way was estimated to be between 120,000 and 200,000 light years. Another interesting fact is it takes our solar system about 230 million years to travel around the Milky Way. The Milky Way's best known feature is its bright, luminous disk of light. As mentioned in the previous slide, this bright disk of stars, which also houses our sun, has been estimated to be around 120,000 to 200,000 light years across. Beyond the Milky Way's disk of light lies a massive disk of gas, a vast halo of dark matter which is assumed to be composed of particles which are invisible to us. Dark matter makes up 85% of the matter in the universe and is called dark matter because it doesn't appear to interact with the electromagnetic field. This means it does not absorb, reflect, or emit electromagnetic radiation, which makes it incredibly difficult to detect. Dark matter is considered to be the glue that holds the universe together, and while we may not be able to understand or detect dark matter itself, we can observe its gravitational influence on light itself or other objects in the sky, as it affects the motion of stars and galaxies. While it's been estimated that the Milky Way was larger than originally thought, additional research was needed to confirm this. New research by Alice Deason and her colleagues at Durham University in England have found the Milky Way is much larger than we previously thought. Using nearby galaxies to find the Milky Way's edge, they have determined that the precise diameter of the Milky Way is 1.9 million light years. So, how did they figure this out? To find the precise edge of the Milky Way, Alice Deason and her colleagues conducted cosmological computer simulations of how giant galaxies in the Milky Way form. More so, they wanted to study cases where galaxies formed side by side, in the same way that the Milky Way and Andromeda did. The simulations showed that just beyond the edge of the giant galaxy's halo, the velocities of similar nearby galaxies dropped. The simulations were confirmed with observations made with telescopes, observing our own Milky Way. They found a similar drop in speed of smaller galaxies near the Milky Way. This drop in speed occurred 950,000 light years from the center of the Milky Way, and it was determined that the precise diameter is 1.9 million light years. We just talked about how Alice Deason and her team used cosmological simulations to determine the precise size of the Milky Way. But what exactly are cosmological simulations? Cosmological simulations are computer-generated models that astronomers use to study the cosmos and celestial phenomenon. They use a virtual universe that has our laws of physics applied to it and a set of conditions to simulate. These simulations allow astronomers to study things like the emergence of structure in the universe and can perform trillions of calculations throughout the simulation, often generating more than 500 terabytes of data. For context, 500 terabytes of data is more than 3 times the data that the Hubble Space Telescope has collected in its lifetime. Large phenomena in the universe can't be studied in a laboratory, so the mathematical calculations in a computer simulation become the laboratory. One invaluable way that simulations assist astronomers is in studying how and what dark matter is and how it behaves. Dark matter cannot be observed directly, but it can be modeled in computer simulations. So what is next for the research? With the knowledge of how to determine the edge of the Milky Way, astronomers can continue to map out and refine the edge of the Milky Way. They will also be able to determine the true mass of the Milky Way galaxy. This is significant because the more massive it is, the more gravity it will have, and the more smaller galaxies will be orbiting around it. As recently as 2018, the Milky Way was estimated to be around 200,000 light years in diameter. In a mere 2 years, we have discovered that it is, in fact, 15 times wider than we originally thought. With modern technology and cosmological simulations, we are beginning to understand the Milky Way in more detail than ever before, understanding its properties, origin, and what the future holds for it. So far, we are aware of 60 known satellites orbiting the Milky Way, but we suspect we'll be discovering many more with the knowledge we now have. It is an exciting time for discoveries within our home galaxy.